All right. Hello, everyone. Welcome. I have a couple of quick logistical announcements before we hop into this topic. The next week is spring break, so that's why we're not having any class next week. You're probably already aware. But what I wanted to mention is that the week after the spring break, so this week up here, we're supposed to have 17th and the 19th. But I'm going to be out of town on those 2 days. So I'll be in San Francisco at a conference. But we also have class those days. It's just I'm going to have it remotely over Zoom instead of in person. So no in-person class on the 17th or on the 19th. You'll actually notice that these are listed as work for the projects anyhow. So I'm not going to be covering any new material on those days or anything like that. We're going to start seeing a lot of work days on the schedule. Now we're in semester since we're kind of getting ready to switch to project mode. So, I'll be available on Zoom on these days. I'll then post that link, once we get back from spring break. But it'll probably be more like office hours, more just available for me to help you out, especially as you're getting started on the project. Make sure that you're up and running and answer any questions that you have. Make sure you're working on the project way. So just want to make sure you're aware of those. I'll post an announcement on Canvas after spring break with the Zoom link and all that fun stuff. The other thing I wanted to make sure you're aware of is that this week, so before spring break, before you go home for spring break, we actually have our first project due date coming up. It's a very small one. I posted an announcement on Canvas about this yesterday regarding forming teams. So if you click on the team formation box right there, there's a link to fill out a form. Only one of you needs to do that for your whole team, just so that I know who's working together. If you need to find a team, so if you still haven't formed a team yet and are hoping to figure out who you can work with on the project, please come to class on Thursday. I will have time set aside on Thursday to get people in the teams who don't have teams yet. If you, don't get teams submitted by Friday, that is going to affect that portion of your project grade. It's literally like the easiest 10 points to get in the whole class. No reason that everybody shouldn't get those 10 points for forming a team. So please, come to class on Thursday if you need a team. There will be time in class on Thursday where I will help you find a team, find people to work with if that is something that you need. Also on Thursday, we're going to be doing the project kickoff. So I'm going to be, starting the project. I'm actually going to kick the project off and get it started together as a group, because getting started is actually quite tricky. So I like to start the project all together as one big group, make sure everybody's up and running and off, moving in the right direction. So that's kind of what the goal is going to be for Thursday. But as far as today goes, we're entering our last pre-project unit, which is based on clean code. So we're going to be talking about a few different concepts regarding clean code today. And what we're really after is code that is not just functional, but code that is also written well. So I think one of the things that we get in the bad habit of doing, especially here on is for a lot of these homework assignments, we don't care how well the code is written. We just care if it works or not. For a lot of homework assignments, you just have to write the code, pass the tests, and that code can be ugly or not ugly, as the case may be. More often than not, I think it's probably more on the ugly side, right? But if we are working on projects over a long period of time, especially, having code that is clean and well written is very, 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 very important. We want to be able to make it so that if, in the next week or the next month or the next year, someone comes to look at that code, maybe even myself, I can just look at it and understand what's going on without having to do a lot of extra work, extra things to figure out what that piece of code is supposed to be doing. So we're going to focus on two clean coding topics today. I'm going to spend the first half of class talking about naming, and then we'll spend the second half of the class talking about functions and methods. And we're going to go through some examples and hopefully get you some practice cleaning up some code yourself as well, which I think is actually kind of a good point, right? All the rules that I'm going to discuss with you today, all the clean codes in this class, I want to make it clear that I don't sit down and write code that looks perfect the first time. I write code that's messy, and then I take the time to go back and clean it up afterwards. So that's really the skill that I'm trying to train you for. If you're getting paid to do this, that's part of the job. If you are a professional developer, part of the job is writing code that not just works, but is also well written. If it's just a personal project, then not as big of a concern. And I still regularly write code all the time that is not, you know, pristine and up to these standards. But if I'm getting paid to write that code, you better believe that I am going to take the extra time to clean it up, make sure that it follows some good clean coding guidelines. And that's what I want to talk to you about today. So I'm going to start by reviewing some general rules for naming, and then we'll actually put those rules to use by taking a look at an actual code example and analyzing the various names that appear within that code example. Let's start by writing down some basic rules when it comes to naming. So I'm going to make a new text file so I can write down some notes. It applies to multiple things, right? So there are many things that we get to name in our code. We get to name, of course, variables, and that's a big one. We also get to name methods. We also get to name classes or interfaces, right? Objects, things like that. And this isn't even a complete list. There are other things that we get as part of our coding jobs as well. And so the names that we choose for all of these things are important. Um, what are our goals? Our goal when it comes to naming things is readability or understandability. They kind of mean the same thing as far as I'm concerned, right? We want to be able to look at that code and understand what it means without having to spend a lot of extra time and effort to decipher, what this variable represents or what this method is doing. If they're named properly, there should be no doubt about those things. I should be able to look at those names and tell right away, oh yes, that's what this variable represents, or that's what this method is. That's what action this method is performing. Consider consider that we spend more time reading code than writing code. That's just a fact. Even when we are actively writing code, we still have to read the code that we are modifying as part of that writing process. So we are really, really optimizing for the reading phase of code analysis rather than the writing, although they do kind of go hand in hand. If it's easy to read, it'll probably also be easy to modify, which is something that we also care about. Is it going to be easy for me to come back and update this code, add some new stuff to it later on? What we are not trying to do is minimize the amount of steps it takes. This feels kind of counterintuitive to some people, right? For computer scientists, we're used to being efficient. We want things to be as efficient as possible, and that's great. But when it comes to naming things, I don't think efficiency is what we're really after. And that's going to show up, as we start to talk about some naming rules. So some of the more common rules that we'll see, especially for variables, we want them to be descriptive. And so by descriptive, some things that we can use to help us make sure that our variable names are descriptive. No single letter variable names. No single letter variable names. This might be one of the hardest ones. If we're coding and we're in a hurry, we have this great idea in our head and we want to get it down on the screen, then of course we're gonna type as fast as possible and using some variable names that I'm just for time. And honestly, great. Keep doing that, but realize that later on you're gonna have to come back and change those single letter variable names to be something a lot more descriptive. Once I show you an example, I think you'll see why using single letter variable names is not necessarily the best choice. But like most rules, there are exceptions. So loop variables like I and J are okay. I is such a common loop variable. Almost everybody understands when it's used to represent a loop variable. That one's okay. right? Using I, J, etc. for loop variables, not a problem. But if it's not a loop variable, then no single letter variable. That's not gonna be an acceptable way to name our variables. We also want to avoid no numbered variables. Oops. By that I mean x1, x2, x3, x4, etc. So I have a variable, I've given it a name. Later on in my code, I decide I need another variable. And oh, I kind of want it to have the same name as that variable that I already made. So I'll just call it data2, right? And yes, that allows me to create my new variable, but that is a terrible, terrible variable name. Consider if you extend that example out, right? If you only have, data1 and data2, sounds so bad. But if you extend it out to data 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, it starts to get really ugly really fast. What's the difference between data 8 and data 5? I don't know. I have no idea. Those names do not distinguish between those variables well enough for me to understand what the difference is. If you find yourself in this situation where you're trying to make variables that are numbered, that's really an indication of one of two things: that you need a collection, like an array or a list, or something like that, or you need more methods. Because if we have more methods, we can take advantage of the variables that are created with methods can only be used within those methods. They have method level scope. So then we actually can create the same variable with the same name in multiple different methods and not have that conflict, the variable names. So no numbered variables, that's another very common thing that I see that is can be a hard habit to break. There's this concept of noise words. So we want to avoid this idea of noise words. These are words that don't add any meaningful information. Oftentimes they're going to be like connectors. So things like a or the are not really appropriate to include as part of a variable name. Best case scenario, they're just taking up extra space and they're not conveying any additional information about what that variable represents. Another one that I see all the time, data. Data is a terrible variable name. It's lots of different world. This is too generic. This is too generic. Another example of what I would consider to be noise words. We'll actually see an example of this when we look at some code in a second. Words like array or list. I don't need you to tell me that a variable is an array or a list. I can actually see that when I look at the type of the variable, right? So telling me that again as part of the variable's name is redundant and is taking up more space without adding any additional information or any additional value to that variable name. So we definitely want to make sure to avoid using those redundant words as part of our variable names. We want our variable names to be pronounceable, which seems maybe a little trivial, right? I'm encouraging you here to use full English words to describe your variables. Don't use abbreviations. Abbreviations are hard to pronounce. Spell it out. Make it explicit. Another reason why it's important for our variables to be pronounceable, we're going to have to talk about them. If I'm working on a big project with lots of different people, right, the chances are I'm going to have to talk to those people about the project. And if I need to talk about a particular variable or a particular method, then I should be able to say that to another person and have them understand what I'm talking about. If it is a series, if it's an abbreviation or something that's hard to say, it's going to be more difficult for us to have that conversation. So we really want our variables to be pronounceable, and they should also be searchable. Because a lot of times our code is going to get big. We're going to need to focus on a certain section of it. So being able to search for things effectively is important consider of the rules that we've discussed, right? This one is inherently unsearchable, makes it harder to search. If I have 10 different variables called the same thing, then when I go to search, I'm gonna have a whole bunch of results. And I need to figure out which of those 10 different variables is actually the one that I'm looking for. So avoiding numbered variables, avoiding single letter variables is gonna automatically help us with the searchability of our variables in our code, which is an important thing for us to consider. Um, so I think everything I've talked about so far is variables, but it's also worth talking about methods, the names for methods. These should be verbs. Let me make that more explicit. Names should be verbs. Methods do something. They perform some sort of action. So their name should be verbs to reflect the fact that they are performing some action. They're doing something. Whereas variables and objects, those names should be nouns. All of our variable names should be nouns, and as well as the names of our objects, names of our classes. Those should also be nouns. Those are things. So what does that mean? You know, if I'm creating a class or I'm creating a variable and I can't think of a good name for it that is a noun, maybe that's an indication that it should. Maybe what I'm talking about is actually a method or some other piece of my code. These are just nice little mental checks we can use to help us decide if our variables are appropriately named, if our methods are appropriately named, and if everything is where it should be within our code. All right. There's a whole bunch of other rules that people can and will argue about when it comes to naming things, but for the sake of time and conciseness, we're going to focus on this set of rules and take a look at an example. So I made a repository with some coding examples for us to take a look at today. If you're on Canvas, you can click on the clean code for naming, and there's a link right here. It says naming repo, which is the repository that has the coding examples for today in it. So if you'd like to follow along with me and work on these exercises, go ahead and click on that link, grab the GitHub repo link, and then go ahead and import it into VS Code. I've actually already got it in VS already once this morning, so I've already got it loaded up, but hopefully while I've been chatting about it, you've also been loading it up into VS Code if you'd like to follow along with me. And I'm going to start inside of this example package. There is one called Dice, and this is an old CSE 131 assignment. The intro class here. Maybe it's possible that you've completed this assignment before, but even if you did, it's probably been a long time, probably years, since you've seen or thought about code that this particular assignment. If you've even seen it before, well, it's not well written. So our goal is to try and clean it up. And the one thing in particular that I would like for you to take note of is that the way that it's written now, there are some tiny clues as to what this code is doing, but it's very difficult to decipher what, overall, if you had to describe what this code is doing in English, it's very hard to decipher exactly what's happening because the variable names aren't really helping us out a whole lot. They're not descriptive. There's a lot of one-letter variables, which we talked about as being very much not what we want. So there's just a lot of general code quality issues with this particular assignment that makes it very, very difficult. If I was working on this part of a project and my task was fix a bug or I had something, not super thrilled because before I would feel comfortable enough to even fix the bugs or add something to this code, I would want to clean it up, make sure that it's understandable. I need to know what it does. Bugs, so I know what this code does. And knowing what that code does is going to be very difficult until I have some proper variables, some proper names for things. So what I'd like to do is actually rename all the variables in this example and show you how you can do that using VS Code to kind of help you out. I am able to do this pretty easily because I know what this assignment represents. So I know the context. I actually know what these variables are supposed to represent. But, you know, as a challenge, see how much you can figure out just from context clues. Kind of remember what this code looks like because we're going to modify it a lot today. We're going to refactor this code quite a bit today. It's going to look a lot different at the end of class than it does right now. And hopefully, if we do things well enough, it'll be a lot easier to understand, a lot easier to use after we, fix some of the quality issues. Before I rename anything, though, let's just go ahead and run it. See what happens. I actually think it might error out. Oh, yeah, it did error out, but not for the reason that I expected. I'm actually not even worried too much about running the code today. That is not, we're focused more on the readability of the code than the function. But the function, when we rewrite, should do so in such a way as to not break anything. I'm assuming this code does perform a task already, right? So I don't want to interfere or interrupt with any functionality because currently this code to make it more readable. We have a name for that. That is called refactoring. So refactoring our code is anything that changes the code to make it more readable or to reorganize that code without changing the functionality. So the code does the exact same thing after refactoring as it did before refactoring. It just looks different. It's just written in a different way, hopefully to make it easier to understand, hopefully to make it easier to follow. But let's go ahead and start trying to rename some of these variables, starting with these up here at the top. You've probably already gathered, this is one big context clue, that this is a dice simulation. So we're going to be rolling some dice. There's some other clues that indicate that, like this word here, roll. So clearly we're rolling some dice. And so a better name for this, instead of D, would be to say, this is the number of dice that we're rolling. Let's use VS Code to change this variable name. I'm going to highlight it and then right click on it. And the option that I want is right here. It's called rename symbol. This can be used, the reason why it says symbol as opposed to variable is that it can be used to rename methods or classes as well as variables, but we're going to be using it a lot for variables. So, all right, if I click rename symbol, I now have a box that pops up and it's waiting for me to type in what I want the new variable name to be. So I'll type something that's a bit more descriptive, such as number of dice. And you can see that after I do that and hit return, anywhere that variable is, right? It understands scope of variables. So it's able to rename that variable at single points in the code where that variable is used. And we want to go ahead and keep doing that process for this. So this one I think is a lot harder to figure out what it actually represents. But if you see that we're creating an array down here on the next line. So really what we're after is that I'm going to take 4 dice and I'm going to roll those 4 dice 7 times. So this is the number of rolls that is being performed, or the number of throws, I guess. Number of rolls. And wow, you can see that even with those 2 variable name changes, the next chunk of code already looks significantly different and has a much, things are starting to get bigger. That's not a bad thing. Here's a classic example of a terrible variable name. I do this all the time. So I am human. I don't name rules every time myself. Sometimes I'm in a hurry. Sometimes I don't want to sit down and think of what a good variable name should be. I just want to get the code out. I named a variable array. Writing sloppy code is not a bad thing. I don't want you to feel bad for writing code that has bad names or is sloppy. We just have to clean it up. So a better name for this one, you can see that it's a 2-dimensional array that's keeping track of the number of rolls as well as the number of dice. So it's really a table of all of the dice that have been rolled.
So that's probably what an appropriate name would be. Dice roll table. Something along those lines.
There's some subjectiveness to this. Actually, I was bit of reservation about using the word bug. That seems like one of those noise words that's really giving a whole lot of additional information. It's just taking up space. So there's some subjectivity here. If you don't agree with the name that I have, that's okay. And there's not always going to be one right answer. I hope, though, at the very least, you can agree that, the names that I'm choosing now are better than the names that I originally started. So if we keep going, there's really only, I think, 5 or 6 more variables that we need to look at and try to figure out. This one is really tricky. I'm not sure how you would figure out what this variable is supposed to represent without doing a lot of work. But um, fortunately, I know what it's supposed to represent, so I'd probably change this and call it a frequency of sums. So when I roll 4 dice, that's going to all sum up to about how many those sums. That's what that particular array is supposed to represent. Notice how much more apparent that is with a good variable name than with, a name f, which doesn't really convey much, except the tiniest of hints about what that variable is actually doing for us. And so then we're on to these next few. This one s, I can see it's used down here. I'm adding something to it. This seems like a classic sum variable. So this is going to be a variable. Now, some people might call it sum. Consider that good enough. I agree that sum is a better name than s. So that is a step in the right direction. But can we be even more? Can we be even more explicit about what this represents? It's a sum of dice, right? Or the sum of a roll. Sum of a roll of the dice. So if you can provide a more descriptive name, I am much in favor of that. Brevity is not what I'm after here. I'm after readability, which means my names are going to get longer and more descriptive. Now, this next one's kind of an interesting one. What this one is doing is it's used to count how many roll yachts. Which for you probably know exactly what I'm talking about if you played the dice game Yahtzee. You get a Yahtzee when all of the dice show the same number. So if they were all 4s, that's a Yahtzee. If they were all 2s, that's a Yahtzee. But if you've never played that game before, you're probably like, what the hell is a Yahtzee? What does that mean? That is a term that is not universal. Necessarily know what a Yahtzee is. This is a good example of being careful when using technical terms. When naming your variable, the term the technical terms, but you have to know who's going to be looking at this code, what they might expect. I think, instead of using that potentially uh, tricky term Yahtzee that not everybody's going to know, it might be better to, describe this in more plain English terms. So we're really using this as a counter for when all of the dice are identical. So number of identical rolls. I don't know, it's a little tricky to think about how to say that more plain English without potentially loaded term. But it's pretty good. It's better, I think, than it was. Number of identical rolls starts out at 0, and we're almost done. We just have a few variables left. I'm not going to touch I or J, even though they're single letters. We allowed them to exist as part of the convention of a loop variable. But this one here is supposed to represent the roll of a dice. So I see math.randoms being used on this line. This is supposed to represent a single roll of a dice. So die roll. And are there any other ones after that? I think that might have been the last one. I think that might have been it. Awesome. So, compare where we are now versus where we started, you'll see that our code expanded. It was bigger. Actually, I would say that most of the time after I refactor, I will have more code, not less. Again, consider what we're refactoring for. We're refactoring for readability, understandability. So I'm going to be including more information, putting more organizational kinds of structures in my code. So it makes sense that our code would get a little bit bigger after the fact. Writing code that is small and tiny is not the goal here. So we're going to accept that as part of, one of the side effects of making code that is readable and easy to understand. And after making these changes, I mentioned earlier that there are some bugs in this code. I think it's actually a lot easier to see where these bugs are now that we are looking at better variable names. For example, this line that I was just looking at a second ago that's supposed to represent the roll of a die. Well, I can see I'm multiplying by 7 here. Actually, that's not right. Die only have 6 sides on them, and I probably should, I think, right? I think that's if I'm trying to generate numbers between 1 and 6 on that line, the text before I have the context provided by these descriptive variable names. There's other bugs in this code as well. I'm not as concerned about those for the purposes of this example, but one of the ones that I think is easier to see now, you can see this first loop iterates I less bounded by the number of dice and j bounded by the number of rolls. But if you look at where the array was created, the number of rolls is given as the rows and the number of dice is given as the columns. So these two are kind of out of sync with each other. One of those things needs to change, right? Either I need to flip-flop the two up here, or I need to flip-flop the two as part of the loop, one or the other, to make it consistent. Those are bugs that are the initial costs. At this point, though, I would like to turn it over to you all. I'm going to turn you loose on an exercise. In this same repository, if you've got it cloned in VS Code, under the exercises folder, there's a file called number thing. So I only mess with variables here. I didn't have any methods or anything else to mess with this example. But this example, I want you to focus on not just the variable names, but also this is a terrible name for a class. See if you can figure out, this is another, 131 assignment that maybe is a little bit easier to recognize. The last one I showed you. Even if you don't recognize it, see if you can use context about the code that you have to determine what this class actually is representing and give it a better name. And then once you've done that, revisit each of the variables. Like here, I see a single letter variable name. That's obviously going to need to be changed. It's not a good name for it. And also the names of the methods need some attention as well. I'm going to give you 5 to 10 minutes. You're welcome to work on this in names. Rename as much of the stuff as you feel is necessary, and we'll go through this in 5 or 10 minutes. Thank you. Tired of me using 131 cents. Okay. Oh, that's. Oh, sorry. Okay. Okay, so it's like. So wait. Breathing. So, all the reason. So let's just add. Oh, we're not changing the info line. God is very popular. And also, oh, and this one here. But she doesn't have. You won't leave. Can't just highlight just the word. Even if I child for action. Over. I've never seen anything like that before. I'll find you. What change comes to I one guess maybe is that if you were to fix the name of the class, that might help. Since class names are supposed to be capitalized, so that might be part of the reason why it's grabbing more than it should. Oh. Why still fun? Yeah, I've not seen that one before. I'm sorry, I don't know how to fix it. That's not a bug that's. It's very frustrating though. You might try looking it up on Google and see if you can find some help online. Sorry, I can't be. One or two more minutes on this one. Alrighty. If you didn't quite get finished, that's totally okay. It was absolutely a lot of fun and interesting to listen to y'all talk about this and try to figure out what the heck this code is actually representing, what it's actually doing. And I think at least some of you managed to figure it out. Figuring this out, figuring what the class is probably the most important thing because the rest of the code will make a heck of a lot more sense if you can actually apply a meaningful name to this class, and the one that I would probably choose is fraction. I believe this code is supposed to represent a fraction. So if I rename it to fraction, you can see that that already has a pretty significant effect on what the rest of the code looks like. And I'll immediately from there turn my attention to these instance variables. This one's called top, and this one's called b, probably for bottom, right? But you know, if we're saying this is a fraction, well, this has a more appropriate name. This would be called the numerator. That's what the top of a fraction is called, right? And the bottom of a fraction is called a denominator. And so, okay, great. Now you can see that just making those changes affect code significantly to the point where I can really start to see that, oh yeah, this is the act of adding fractions, right? When we add fractions, we multiply the denominators together, and then we add the product of the numerator and the denominators. We do cross multiply, I guess. It's been a while since I've thought about fractions, to be honest with you, but the other thing I wanted to turn my attention to were the names of these methods. So do adding, technically that is a verb, so not violating that rule, but it feels a little clumsy. It feels a little clunky. This is a case where I actually think a shorter name would be more appropriate. Just say directly what you're doing. I'm adding. For this one, product. That clearly violates the rules. Product is a noun. Now, being produced. We're multiplying fractions here, producing the product of two fractions. So it's somewhat accurate, but not a good name for a method. Again, it should be based on the operation that's being performed, not the result that's being generated. And so from here, I think you can see while there's still some more variables that need to be cleaned up, like these very poorly named ones, right? Now that we have that additional context, it should be quite a bit easier to figure out what's going on. And then this method down here, probably another clue as to what's going on. This is the greatest common divisor. But hold on a second. Greatest common divisor, that's an out. So that's actually not the best name. How do we fix that? I might say compute. But then, oh wow, that is a long method name. Is that a problem? Maybe it doesn't feel great. Maybe you're not used to seeing methods that are that long. It's not a problem, though. Again, more description, better. Keeping things readable is better. So I'm always going to choose the longer, more descriptive name as opposed to a shorter name when possible. There's other stuff to fix up in here, but I think I've covered enough. I want to move on to our next topic for today. So same kind of idea. I'll talk through some general rules about methods, and then we'll try to apply these rules to an actual example. So methods, I would argue methods, knowing what the good rules are for methods, trickier than naming. Most people understand that variable names should be nice and descriptive, but knowing how methods should be written is a bit more complicated. And to boil it all down to one word, methods need to be small. When I said that, I'm hoping, betting that an image of a small method popped into your mind, right? How small is small? Whatever popped into your mind, it's smaller than that. Methods should be small. Very, 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 very small. As small as possible. Large methods are not what we're after at all. Quite the opposite. And another reason to keep us on the track of small methods is this idea that they should do one thing. They should do exactly one thing and do that thing well. If a method is trying to do more than one thing, that's an automatic indication that should maybe be split up into two separate methods. So if there's more than one thing happening, that method has extended its responsibility. So being able to do one thing and do it well is the job of a method, and that means our methods are going to be small. How small is small? Well, let me introduce you to the rule of 20. So no methods should be greater than 20 lines is what the rule of 20 says. This isn't the last time we'll see the rule of 20 here. It has a few different applications for us when it comes to clean coding guidelines. But in this case, we care about how long a method is. And again, I want to reiterate, 20 lines is the upper bound. So I would prefer smaller, possible. If I can get it down to 5 or 10 lines, even better. Even better. This the author of the book, which this section is based off of, the Clean Code book. It's on the syllabus if you'd like to track down a copy, which I would highly recommend. Actually, I've read that book at least a couple times, and I think it's great for understanding how and why we want to write code that is clean and real. But in that, the author goes so far as to say that if statements and loops should have one line max. I feel like personally that's a little bit extreme. I think this is, an ideal world situation. Should we be striving to make our loops and if statements as small as possible? Yeah. But is that always practical to do? Not always. But think about what that means. The author is suggesting that if I have an if statement or a loop with a big old block of code in it, that I should be making a method out of what is inside of that loop and then calling that method instead of having that big chunk of code put inside of the loop directly. Um, so yeah, some other signs, some other kinds of rules of thumb when it comes to writing methods. The number of arguments, parameters, no more than 3 at the most. So if I'm writing a method, I don't want to see any more than 3 parameters to that method. If I have more than 3 parameters, that is an indication that, well, it's an indication of a couple of different things, right? So more than 3 means either you need more methods or you need more objects. So objects, not really on my list of things to talk about today. We're going to talk about objects after we get back from spring break. But that is a great way to reduce the number of parameters that you need for a method, is to take some of those parameters and encapsulate them with a class. Replace, 3 parameters with one object. That's a great way of taking care of that particular situation. But even further along these lines, I want to point out 3 is the max. It's also not great. So having 3 parameters is like the absolute bare minimum, but it's also not great. And if I can have 2 or 1 or even 0 parameters, that's going to be even better. So that's what we should be striving for. No more than 3 parameters as just a minimum baseline, but fewer than that if at all possible. Like most of the rules that I've been talking about today, though, there's a very big exception to this one. Constructors. So the purpose of a constructor is to make sure that all of the instance variables are set. It's 131 intro stuff right there. Consider if we have a class that has 10 or 15 instance variables, it would be hard for a constructor to do its job with only 3 parameters because it has to set 10 or 15 instance variables. So constructors are the one exception to the number of parameters rule. But if it's a method that is not a constructor, it's a pretty hard and fast rule for me and something that I'll be absolutely looking for on the project, for example. Same thing with the rule of 20. If you have methods in your project that are longer than 20 lines. There are exceptions to that rule as well, I should say, just like there are exceptions to most of the rules. But if I see lots of methods that are greater than 20 lines, it's gonna be something I ask you to pay attention to and fix. Make sure our methods are short and they're only doing one thing. And so, kind of along that idea, making sure our methods only do one thing. Our methods are generally going to fall into two different categories: commands versus query. So a command is saying I want to do something. I want to manipulate some data. I want to perform some computations, make some particular action. Whereas a query is asking a question. And we use methods for both of these purposes. So this idea of a command versus a query is that methods should either do something, that's a command, or answer a question, that's a query, but not both. So a single method should either do something or answer a question, but not both. Remember, we want our methods to do one thing and to do that thing. When we have methods that do more than one thing, that are performing more than one action at a time, we run into what are called side effects. So side effects happen when I call a method that says it's going to do X. It's going to do X thing. And the method does do that, right? It does do thing X, but it also does thing Y. Well, I know it was going to do thing Y. The name of the method just told me it was going to do thing X. How was I supposed to know that it was also going to do thing Y? That is an example of a side effect, something that I wasn't expecting, right? Something that isn't immediately clear to me when calling the method is going to happen. And another very, very important reason why our methods should do one thing, and that thing that they're doing should be right on the label. The name of the method should tell me exactly what it's doing, and if there's code in the method that is not related to that thing, it doesn't belong there. It belongs somewhere else. Before I switch over to the example, I just want to repeat one more time that I don't write methods that meet these rules. I write methods that break these rules all the time, a lot. But then I take the time to come back and fix it up and make it work, make it look better after the fact. That is what I'm trying to train you all to do. I don't want you to feel like there's this pressure on you to write perfect code all the time, because there's not. You can still write code that is not perfect. In fact, it's very hard to write perfect code the first time. Very hard. So write that imperfect code and then clean it up. That's kind of what I'm hoping you take away from this little section. But let's go ahead and start to try and apply some of these rules to actually the same example that we were working on before. I want to go back to this dice example and try to get as many methods out of here as I possibly can. Follow as many of those rules as I possibly can. And we can use VS Code to help us with this. Now, this is a bit tricky. One of the rules that I use when looking for things to, trying to figure out how to get more methods out of this, I'm going to look at the indentation level. So find the deepest indentation level that you can, which looks like it's about here, or maybe up here is also pretty deep indentation level, which is actually, that's another kind of red flag, by the way, that maybe I should have added on here. No more than 1 or 2 indentation levels per method. Forgot that rule, but that's another good red flag for you. If you have a method indenting more than 1 or 2 levels, that's an indication that that method is doing more than one thing and should be refactored into multiple smaller methods. And so when you're trying to figure out where those methods are, right, find a deep level of indentation and look at it and try to think, okay, can I an 8? I'm going to give this chunk of code a label. And you might try and look at it a couple of different ways. So in this case, I might look at just what's inside the body of the loop and see if I can apply a name to that.
but I then would also look at the entire loop itself. So should I treat, should I treat it as just a single block, the body, or should I treat the entire loop as a method? These to go about it. In this particular case, I think we can apply a name to the code that I've selected here. This is going to iterate through and generate the total number of, it's going to generate one throw. So if I'm rolling 4 dice, this should give me four dice. So it should give me one roll of the dice, one throw of all 4 dice. And so in order to turn this into a method, we're going to use VS Code to help us here by highlighting that section of code. We're going to right click it and then go down to refactor, which is what we're doing today. And this option here, extract to method, will do exactly what it says. Notice what happened when I did that. That section that was highlighted got replaced with a method call. It's now waiting for me to name this method. What do I want to call it? I want to call it roll dice, right? Or something along those lines. The method itself was generated down here. And if we look at, some of the it's less than 20 lines, so that's good. You'll notice that the method that we started with also has more than 20 lines. So that was another indication. But the number of parameters that we have, the number of parameters that we have is kind of a lot. Ideally, I would want it to be down to, just 3 or fewer than 3 if at all possible. So the question now is, can I rewrite this code a little bit to get rid of some of these parameters? And I think the answer is yes. For example, for the sum of the roll, I think if we take this variable and actually this probably should have been included inside of the method that I just created. So if we extract this and bring it down here and create it inside of the method directly, that will allow us to remove this parameter that we don't actually need, the sum of roll parameter. So VS Code, did the best that it could to help me, but still doesn't understand what this code is doing. So it still takes a little bit of tweaking on my part as the programmer who actually understands this code to make sure these methods are still going to work appropriately. For number of dice and number of rolls, right? I think we could figure out a way to get rid of those as well, especially considering we have this array. And so we really could replace this with the with a call to dot length to the dice roll table instead of having to pass that variable directly. So now we've eliminated the need for that. And we're still, are we at 3? Oh, we are at 3 now. So we've hit the bare minimum. I actually think we could probably remove this one as well, but for the sake of keeping things moving, since we are running a little bit short on time, I'm going to see if I can come up here and find, oh, well, I made a bug when maybe I just need to do, maybe I just need this variable in both methods, right? Maybe I need it down here and I need this variable up here as well. That is certainly entirely possible. And now this method call is mad because I took some of the parameters off. So I just need to remove the parameters from the method call as well, like this to match. All right. But I want to keep going. Ideally, so what's my goal with refactoring this? Everything when I started was in main. That's bad. And this is another thing you're looking for on the prompt. Your main method should be the tiniest of all. The rule of 20 does not apply. Yeah, you're good. The rule of 20 does not apply to the main method. The main method has like a rule of 3. I don't want to see any more than like 2 or 3 lines max in the main method. So ideally, I want to get all of this code out of the main method into other methods. So let's keep going. Let's see if I can extract out another, method or two. Maybe this one. This is the one that we're using to find Yahtzees. So I think we could highlight that for loop and refactor out another method. Call it find identical, not Yahtzees, but identical roles, since I want to avoid using that potentially loaded term. All right. And we have four instance variables, or I'm sorry, four parameters, not instance variables, four parameters. But again, I think we could get rid of this one by using the length of the array instead. So that's a nice way to get rid of one of those parameters to keep us under 3 parameters, which is our ultimate goal here. And our main method's getting even shorter, but still quite a lot going on. All right, what's next? Maybe this one? So I'll grab my next for loop and refactor this out into a method. What's this method doing? So the method that I had before was doing one throw. This method is doing all of the throws. So what would I call it? Uh, perform throws or something like perform rolls, multiple rolls, maybe? I don't know if I'm a big fan of that name, to be honest with you, but I'm running a little short on time, so I'm going to keep forging ahead. If you can think of a better name for this method, I'd be happy to chat with you about it sometime. But yeah, wow. Again, I see 1, 2, 3, 4 parameters, but just like the last ones, I can get rid of this one by referring to the length of the array instead. So we'll replace that like so. Dice roll table dot length. And get rid of that. And then finally, if we look at our main method, you can see that it's shrunk quite significantly, and there's really only a little bit of indentation happening left. I actually think this could probably be extracted into its own method down here to print out the sum of stuff at the end, but I'm going to go one step farther and do everything else that is remaining in my main method and extract that out into its own method, and we'll call that run dice simulation. And I'm pretty happy with this. So we can see our main method is now shrunk down to one line. That is great. That is exactly what I want my main method to be. Main method should call a method and get out of the way. That's all the main method is for. You can see that I've got 1, 2, 3, 4 methods down here that have all the work containerized, right? Abstracted out. I actually think these methods aren't perfect. If I had more time, I would probably spend more time tweaking these and trying to fix them and make them even better still. One thing that I think would help us a lot, or will help us a lot when we eventually get there, there's no objects. I'm not using any object-oriented programming in this example right now. That is the next topic that I want to talk to you about after spring break. So we'll actually revisit this again and try to inject some objects in here, and that'll reduce the number of parameters even further. That'll really help clean this code up quite a bit. But consider where we started today with that initial code that was all in main with the terrible variable names. Compare that to where we are now, where I have lots of methods, lots of well-described variables. This code, while does the same thing as it did when we started, understand these are the test. These are to test our code, which is important to us. We care a lot about unit tests. So when everything was in main, we had no way of testing this code. But now that everything's in its own methods, I could write show that this code actually does what it says it does. That's something we care about in this class. So yeah, we will revisit this exercise one more time, but I have reached the end of what I wanted to cover with you all today. So what I'm going to leave you with, we have about 12 minutes left. There's one more exercise in here. It's called Gambler's Ruin. This is another very, very, very famous intro that I'm sure some of you probably remember, either as a student or a TA or both. And so what I would like for you to do is spend the remaining time doing what we've been doing today, which is cleaning up the variable names and extracting methods out of this, as many methods as possible, as you possibly can out of this code. I'm not going to go through the solution to this today. I don't think I have enough. Solution Thursday. So I would like for you to clean this code up. Bring it on Thursday and we can compare, right? It's not going to be graded or anything, but I'll show you my refactored version. So let's start off on Thursday and you can compare that to how you did. One final thing that I'll point out before I stop talking, let you get to it, is that we have one more assignment left, and this is basically what it is. It's me giving you an ugly piece of code and saying, hey, fix it up, make it look better according to the rules that we talked about in class. So trying to get you as much practice doing this. So yeah, take the last 10 minutes or so of class and fix this up and bring your copy on Thursday, and we'll chat about it at the beginning of class. Let me know if you have any questions or need any help.